Welcome once again. Let's start our discussion. Welcome to the next lecture of physics optional for IS examination. Okay. So particle falling under gravity with frictional force of air directly proportional to V. We are going to learn this. So this is your particle of mass m, point particle, and it is being attracted by the earth with a force equal to mg, and F is the frictional force, which is means the frictional drag of air which is acting on this particular point object, and V is the velocity of this point object in the downward direction. Okay, so if F be the frictional force on the particle due to air, F is what? Your frictional force on the particle due to air. So your frictional force on this particular particle will be directly proportional to minus V. Why negative sign? Because your velocity of the object and this frictional force which acts, both of these will be in the opposite direction. Okay, so F is directly proportional to minus V, that is F equal to minus K dash V. Now what is this K dash? K dash is your constant. Whenever proportionality sign is removed, some constant is introduced, so that is K dash. Okay, from FBD the equation of motion is, now from the free body diagram, this is your free body diagram of the object, that is the point object. Okay, so the equation of motion is something of this kind. Now this is mass into acceleration, which is the resultant force on this particular point object. What is it equal to? It is equal to the downward acting weight, which is mg, and minus K dash V, okay, which is the air drag which is in the opposite direction. Okay, so mg minus K dash V equal to m dv by dt, means mass into acceleration. Okay, so mg, this is your mg, and K dash V opposite direction. Okay, so what is this? M dv by dt. So mass into acceleration, that is m dv by dt equal to mg minus K dash V. This is your FBD of the uh, this is the equation of motion which is derived from the FBD. Okay, so eventually this m will go to the right hand side, then what will happen? Dv by dt, this m and this m will cancel out. Okay, and minus K dash divided by m will come over here, and K dash by m will be equal to your K. So now you have to integrate, basically this dt will go in the right hand side. Okay, and this g minus kv will come on the left hand side. So integration 0 to v dv divided by g minus kv equal to integration 0 to t dt. Okay, this is your expression which you will get from here. Now never say that this dt is being multiplied on both the sides. It is not like that. I have already told you that this is a differential quantity, not a simple digit. So you cannot call it to be multiplying dt on both the sides. You cannot call it like that. Okay, so dv divided by g minus kv integration 0 to v. Okay, and dt is over here, so integration 0 to t. When time t equal to 0 was there, at that time the what we can say velocity of the point mass was 0, because at time t equal to 0 it was just dropped. So as it was just drop at that time, so its velocity was 0 at that time, and at time t equal to t it has attained some velocity v. So 0 integration 0 to v dv divided by g minus kv equal to integration 0 to t dt. Now you know this very well, then this dt will become t, so it will become t, and uh, 0 to t means you will put the upper limit and the lower limit, this will become t, and 0 to t. Okay, so t minus 0 will be there, so it will become t, and this will be ln g minus kv divided by, this will become logarithmic form. Okay, you know this very well, that is this particular type of integration yields you ln. Okay, log to the base e, that is ln. So minus 1 by k ln g minus kv from 0 to v. Okay, putting the upper limit and the lower limit, you will get this from the formula log a minus log b equal to log a by b. Okay, and this k we will take it to the right hand side along with this negative sign, so it will be minus kt. Then log to the base e is over here, so e to the power minus kt will come, so e to the power minus kt. Okay, and g minus kv divided by g is there. Okay, so what will be your value of v? Value of v will be g by k into 1 minus e to the power minus kt. Okay, g by k, what will be your value of v? How did you find out v from here? Simply by so this g by g will become 1, and this will be minus k by g times v. Then 1 will be taken to one side of it, and you can find out the value of this v. Simple mathematical steps. If I am not going to discuss the mathematical steps, those are very easy. Everyone understands the mathematics behind this, because you are not a student from the bio side. Okay, you are not a student from the bio side, you are this kind of student, what we can say, already having mathematics. Okay, you are this kind of student, so you have a mathematics background. As you are a physics student, you already have a mathematics background with you. Okay, if the viscous medium is long, then what happens? If suppose the viscous medium is long, then t tends to infinity. So suppose the viscous medium is long, then what will happen? It will take a lot of time to, now over here the body was falling under gravity, and suppose the path is very long. Okay, suppose the viscous medium means air over here, it is air, but in some other case the time required will be very huge in case of a long medium. This case doesn't apply over here, because if you take the path to be too long, you will go at a much higher height from the earth's surface. Getting it? Okay, if you take that, this viscous medium means air over here, this viscous medium air, if it is too long, okay, if it is too long, then what will happen? Your height of the object from which it is dropped, that will increase many folds, and as it will increase, so it will be very much comparable to the radius of the earth then. So this particular case doesn't apply to a particle falling under gravity. Which case? If the viscous medium is long, this case. Okay, up to here everything applies. Okay, up to here everything applies, but this particular line, if the viscous medium is long, then t tends to infinity. This particular thing doesn't apply to a particle falling under gravity. Okay, this particular thing applies to some other particle. Okay, which is in under a similar situation of constant force field. Okay, so e to the power minus kt will become what? It will tend to 0 in case of t tending to infinity, when the medium is very long. So this term will vanish then, and as that term will vanish, why this term will vanish? Because e to the power minus infinity will be over here, it will come. Okay, e to the power minus infinity will come, so e to the power minus infinity is 0, right? Because 1 upon what will it be? E to the power minus infinity is equal to 1 upon e to the power infinity, and 1 upon e to the power infinity is 1 upon infinity, and 1 upon infinity is equal to 0, right? So that's the thing. And this term, as it is 0, then what will happen? V equal to g by k. That is what? That is your terminal velocity. That will be the maximum velocity attained by the object. Okay, the velocity will become constant if t tends to infinity. At that particular time, the velocity will stop increasing. And it will reach a terminal velocity v equal to g by k, and the velocity will become constant after infinite time. Okay, That particular velocity is called as terminal velocity. One recommendation I would like to give you, if you are having difficulty in understanding anything in this particular lecture series, then you should make the notes out of these slides. Just pause the video, make the notes, and after that you yourself try to understand the situations. If you read the notes carefully, you will understand everything, each and everything. Okay, there is nothing uh, rocket science in this. Okay, so v equal to g by k, which is terminal velocity. Now the above equation can be written as how can it be written? Which equation? This particular equation. How can it be written? Your v can be written as dx by dt, because velocity is equal to rate of change of displacement. So dx by dt will be there, and g by k is there already. 1 minus e to the power minus kt is there. So 1 minus e to the power minus kt is there. Okay. So dx by dt equal to this much. Then this dx will be here. Okay. This dx will be here, and g by k 1 minus e to the power minus kt dt. Right. And this will be again at time t equal to 0, displacement of the object was 0. At time t equal to t, displacement of the object was x. Never call it distance, although over here, as the motion is in a linear line, as the motion is linear, as well as the motion over here is linear, as well as unidirectional. Okay, as the motion is linear as well as unidirectional, so your displacement and distance are going to be the same in this particular case, because motion is unidirectional as well as linear. That's why displacement and distance are going to be numerically equal over here. But in practice, in general, you should never call it rate of change of distance. This is not rate of change of distance, this is rate of change of displacement. You should call it like that only. Okay, in this particular case those two will be equal, because this is unidirectional as well as linear kind of motion. So integration 0 to x dx, g by k is there, 0 to t, 1 minus e to the power minus kt, and dt will be over here. So this will be x, right? Dx will become x, and 0 to x is there, so x minus 0 will come, so it will be x. G by k is there already, right? And 1 minus e to the power minus kt dt is there already. So this 1 dt will become t, and t minus 0 will be here. And what is the integration of this? I don't need to tell you. These are just mathematical manipulations. You can yourself understand all this. Okay. This is the final expression which you get from here. That is the expression for displacement. You get it like this. Okay. It looks something like this. Now we will move on towards our next topic, but we will learn about the next problem in the next class. Okay, the next problem will be taught to you in the next class. Thank you very much.